So I'm going to be showing you the best I can on how to replace an HDMI port. Specifically, this is on a PS5, but these techniques can be brought over to a lot of different models. This one definitely got our work cut out for us. I'm not necessarily anticipating fixing this board, as this is just a donor trash board. See that the person that worked on it before us got a little silly goofy with the amount of solder and definitely lack of flux we're seeing. Common sign and things to watch out for yourself whenever you are soldering. You can see definitely use a lot of flux because there are a lot of peaks and bridges in the solder. Flux just helps the solder kind of flow on the board and avoid situations like this. Especially you would see here with the peaks in the solder legs, or solder joints rather. I'm also seeing the diode right here is completely off. You can see it's burned a good amount. It looks like they tried to use, I don't know if that's, I have to assume this is flux, but it is absolutely destroyed, just burned to hell. But I can't imagine, it's like a sticky substance. I'm pretty sure it's flux, but they just kind of put one dollop on there and thought that that would be good enough. Jesus Christ. Okay, well, I'm going to go ahead and take the port off before I do any cleaning, because it also helps to remove flux from the board while the board is hot. So that way it's still in kind of a liquidy form so it doesn't stick as much. And back. I know this is kind of not exactly an opportune angle, but this is the best setup I have for recording this. I'm trying to show you the best way to pull it off easily without doing additional damage. You definitely want to heat it from the underside in most cases. The PS5 though is a fairly thick PCB, so sometimes you're going to have a little bit of trouble just heating it from the bottom to pull it off. So you might have to heat it directly on the pins right here. The only problem with that, of course, is that it is going to cause the plastic on this back edge to start melting a bit. Let's see if I can get the camera a little better. Kind of silly, but I don't have an actual PCB clamp or anything at home, so I'm just using a heavy enough heatsink to kind of hold it down. My hot air station at home here is not good at heat regulation, so I'm having to kind of max it out on my end. Typically on most professional hot air stations, you can get away with around 450 degrees Celsius, like 80% airflow. But on mine, I kind of have to max it out, unfortunately. So, you're just going to heat it from the bottom. You don't necessarily want to move it too much. You can see I'm just directly underneath the port. The reason you don't want to move it around too much on this board is because, since it is such a thick PCB, it dissipates heat very well. So if you can kind of at the start move it around to warm up the board to kind of help it flow better. Try to localize the heat as much as possible to keep it warm. See, it's already kind of wobbly. Although I think this wobble is literally just because the joints are awful on this board. I don't necessarily think it's heating up too much yet. There you go. And again, that was just literally using my hot air station directly below the port itself here. That's all there is to it. Now to assess the damage. First of all, not looking too terrible. I can see there's some bridging, some burnt solder. That's kind of to be expected. Missing a trace, and unfortunately that, oh actually, no, that's a ground pad, so it's not necessarily that we need to replace that. I will go over that just to show how to do it, but most of the time you don't actually need to do that. So we're just going to clean the board here, some IPA, and some Q-tips really is all you're going to need. Most of the time at least. This one might be a special case because of how burned the flux is, because that is literally charred. Yeah, Jesus Christ. It's so awful. I don't even understand how people get to this point. Especially with, like, I feel like you can just look up any YouTube video tutorial and you'll see how to avoid situations like this. Okay, so, oh wow, that actually is solder. Oh, that is too. Wow, that is horrific. So what I'm going to go and do here, I'm going to go ahead and apply some mechanic flux. And I know for sure that they were using leaded solder, which is what you want to use on this to remove the non-leaded solder, just because it lowers the melting temperature. So it makes it easier to remove and resolder components, etc. So what I'm going to go ahead and do, I don't trust whatever this person was using because clearly this didn't go well. So I'm going to get some of my own non-leaded solder. I'm going to re-tin these pads. I'm not going to finish off on these pads though, because again, I just really don't trust the job these people did. Hopefully anyone viewing this would share because this is genuinely horrific. Go ahead and give this a clean while it's still hot. And some IPA. You always want to make sure, especially because you can tell that the person that worked on this before me did not do this, you want to clean at every single step of the soldering process or it's just going to become a huge mess. And what I'm going to do here, if you remember I just said that I'm not going to keep any of that. I'm going to fully clear this out. So I'm going to use some copper solder wick to just suck away all of that we just put on there. Because I really do not expect that they did a good job with any of this. And then this is clearly factory solder in these ground holes, at least on the front. I don't think that they refilled it or anything like that. Wow, I forgot how bad the back was. Oh my lord. That is, and that's flux. How do you even get it that bad? That is like actually shocking. I'm gonna bring these peaks down as well, which this tip isn't great for doing what I'm doing, but it's what I've got at the moment. Okay, that's good enough for the moment. I'm gonna do a full clean on it in a second though. And probably what I'm gonna do to try to get some of this away is just go ahead and heat it up with the hot air station as if I was actually going to be using it, just to get the flux kind of liquid again, although I don't know if that's going to be a great idea considering how charred this is. You can see a big ball of solder there. I assume that came from there. So I need to fix that diode. Need to remember to do that. Again, I'm not expecting this board to work because this is a scrap board for a reason, but just for education's sake. And so, like I said, that's just a ground pad right there, but I do want to go ahead and run, I guess, not necessarily a jumper, but I do want to rebuild that pad a little bit. So there's a number of ways you can proceed with this. I generally use wires. There are trace pads you can purchase. I just don't have any with me at this exact moment to work on. Or well, I guess I need to tin the entire pads first just to get them looking nice. So we're going to put light bit of flux all the way across. And retinning just refers to adding more solder onto the pads. That's a simple explanation. I really need to switch this tip out. This is not a good tip for this. Absolutely could have just lost that component just because I'm using this way too big tip. Yeah, we're gonna swap that out. And add some more flux. Oh wow, that actually clumped on there. That's surprising. I guess I don't need to line that pad. That's extremely unexpected. But I'm just gonna go ahead and make sure we get a good clean on this. I almost lost that that fuse right there a minute ago. That would have been not great. The capacitor, may have noticed is missing up there by that, right there. But that isn't required by any stretch of the imagination. Get that sorted. Do a quick visual inspection here. Filters look good. Might be missing a component right there. I'm not exactly sure what goes there, if there's a cap or something, but that feels like, that feels like solder flux, or solder flux, Jesus Christ. It's like factory flux right there that's chipping off the way it does that. It's some sort of glue. And some more flux. Thank God they didn't try to replace this chip. What are you? Oh, okay. I thought that was a scratch on the board for a second. Okay, I do still need that diode. I do not like how that's piecing off right there. Does not feel good at all. Wow. I really don't like how that diode looks. What? Is that a capacitor? What on earth? Where does that even go? Oh, I don't like this. Oh my God. Let me look at this other board I've got here. I know there's supposed to be a diode and a capacitor right underneath on the back side of the board. Although this is a newer revision. The one I have doesn't have that component right there. Wow, this looks horrible. Let me get some flux in there. I'm just going to clean this up a little bit and put that diode back on so I don't forget. Going at 60% airspeed at the moment. And I'm gonna put that there. That's just assumption because that is leaded solder and that has to be leaded for a reason. I'm assuming that they went over it at some point. That still looks stable. That looks good. That's good. The other thing that's good with flux is that solder likes to flow together. Flux helps it do that. So you can just, as long as you've got it in the right position, it'll just push itself into place. And then again, while the board's still hot, you want to clean as much as you can. Obviously be gentle not to mess with any components too badly. But since the metal has, or the solder is clearly already solidified. Oh, that was a little too hot still. Whoops. Not necessarily anything that's going to get harmed by that. Wow, this is actually absurd. Just an educated guess on that capacitor. I do actually have this other board here, and this is a different one. This is a donor board. And it's got, I'm not sure if it's the revision or what, but this is that same trace, and it leads to a blank component. So I'm not sure if that was tinned on accident, either when I went through or whenever the original person went through. I'm probably gonna have to go back and check the video and see how that looked whenever I first messed with it. Again, I know that this isn't the opportune angle, but it's gonna have to be good enough. So the thing you want to look out for here also, let me get my trusty handy dandy heatsink, is there's a number of ways to actually put it on here. Some people prefer to fully clean out the joint holes here, the post holes I mean, just because, which is, I mean, that's fair because like I said at the beginning, you can't necessarily trust the materials that other techs have used. However, I'm gonna just reflow these into it because I think that for the most part, this is the factory solder, which there isn't necessarily a harm in leaving that the same. It definitely looks like they added some more onto the pins from the original HDMI port here. You can see some stuff kind of sticking out of the edges here. So I think that it just genuinely didn't merge at all with the original. So that being said, I am going to leave that in there, but I do want to show another strategy that I commonly use. I'm going to add a little bit of flux here because I'm going to flesh these out first. So what I will do sometimes, depending on the state of the port and the state of the post holes, because sometimes I will fully clean them out and add my own solder in there, but sometimes while it's hot, you can just simply add in some leaded to make things a little bit easier. And like I said, this isn't a perfect solution every time, but just for this, mostly because it's practice, and also because I'm pretty confident that this is just the factory solder that is in the post hole still, I'm going to go ahead and go with this method just because it's going to be a little bit quicker and a little bit cleaner in general. So I'm just going to wait for those to turn that silvery color. I don't think you can necessarily see that super well on camera. I'm doing the exact same technique I was whenever I removed the first one. And then, you can see it's gotten liquidy. So I'm just going to feed that into the post hole. It's going to melt instantly. And not too much because I'm not trying to overfill it. Again, because I am just using this for the port itself. Okay, and there we go. So now I've got some fairly clean post holes. And then while I've got that on, I'm going to go ahead and add some flux and grab the port I'm installing. And again, same thing, just keep heat directly into the port. And you're going to watch, you can see that the solder is a kind of a dull silver whenever it's hardened. And then as it liquefies, you can see it start getting a lot shinier. Especially with the heat I'm using, you might be able to see on camera, it's kind of bubbling a little bit. That's just due to the excess heat. And then this is commonly referred to as the drop-in method. It's kind of the main way you want to put ports in. And then also just to line it up. You can kind of see visually the pins. You can't necessarily see it on camera, but with the naked eye, you can actually see the pins lining up there. And you just want to put slight pressure on the port, not too hard. And you just want to wait until you can see the solder kind of start turning back into that dull gray color as opposed to that bright silver. And that's just to kind of help make sure it's sturdy so the pins don't disconnect whenever you lift off pressure. So now, let's go back onto the microscope and we will check our work. Okay, so we've got this on the microscope. I'm going to give it a quick clean. An easy way to kind of get in there is just do like a little twist method there. That usually helps get quite a bit of stuff out of there. You can also go in with a toothbrush. That's like a very soft toothbrush. That's usually the easy route to cleaning this out. I don't have a soft toothbrush with me at the moment to really demonstrate that. But anyways, we're going to do the poke test, which is very, very simple. You just want to poke all these to make sure that they have a solid connection. Obviously, they will wiggle if they are not fully seated in that solder. So I'm just going to put slight pressure. Obviously, if it is disconnected, you don't want to put too much pressure and actually like break or damage a pin. That all looks good. Another really important thing you want to look out for, make sure that your solder goes all the way through those post holes. If it doesn't fully go through, then it severely weakens the integrity of the port so that any kind of push in there can severely damage it. But gonna do one more quick once over. Make sure that everything looks like it's pretty okay. I'm gonna do another clean as well, and then I'll go ahead and put it back together and give it a test. Again, this is just like a scrap board, so I really don't think it's gonna actually post, but we'll see. Oh, there's something important. Looks like that diode kind of blew off a bit whenever we were heating it. That is something you need to look out for, especially if you have redone something with leaded solder, because it does have a lower melting temperature. It is sometimes fairly easy for this to happen, because obviously I wasn't the one that added leaded solder here, but the person before me clearly did, or else it wouldn't have melted this quickly. Kind of heating it from the bottom, I mean. So we'll just heat that up and poke it back in. It's weird. There you go, and you can see the flux just kind of reconnected to itself there. Let's take a look at those post holes. Definitely a bit of excess there. So one simple thing you can do here, there's a couple different methods for kind of smoothing those out, and I do want to mention there isn't necessarily like a functional purpose to kind of prettying these up like I'm about to do. It's more so for my own personal benefit, my ego a little bit, just because I want them to look good. As long as they go all the way through, they're gonna be fine if they're not super, super pretty. But anyways, what you want to do is you want to switch to a bigger solder tip. So I've only got like a knife tip here. It's like the biggest one I've got. And with a little bit of flux, just put a little pressure, you can kind of sweep away some of that excess solder. What you can also do, oh, there we go. You can see it start sinking into the hole, exposing the pin a little bit, which that's not bad or anything. That's actually kind of what it looks like in the factory too. Or just out of the factory, I mean. There we go. Beautiful. Perfect. Alright, beautiful. And I've got it plugged up now. I'm about to start testing it, but I just wanted to point out something great. Previous person also shredded that coax cable, so that's pretty fun. But I've got it plugged up here, so we're about to, let's see if it beeps. It does beep. No light, it looks like, which is weird. Oh wait, no. You can see the faintest blue light. That's so weird. Barely visible there. But, ooh, getting very hot. Is that a white light? That white's just gone light. Let me see, let me switch over. Getting any signal. Which, oh, whoa. It's gone white again. That's... What? Okay, I'm genuinely shocked. There was so much damage on here. I genuinely... Look at how horrible that is. Wow, that is insane.